Hey everybody, welcome to Carbon Radio. Today I'm going to answer the question, how much money should exist on Mars? I'm going to go through 3 calculations to give us 3 possible solutions, and you can decide which one makes the most sense. So let's get started. All right, so the first calculation we're going to do is going to be simply to look at the volume of a planet and see if it makes sense to scale a planet's money supply based on the volume of that planet. So we know that Earth has a radius of r, and we know that Mars has a radius of about half that of Earth's, so r over 2. We also know that the volume of a sphere is equal to 4/3 pi r cubed, and we're going to assume, for the sake of this calculation, that Earth's money supply is 100 trillion. So I'm going to write out Earth's volume here as 4/3 pi r cubed and write out Mars' volume as 4/3 pi r over 2 cubed. So we can simplify this a little bit to make it easier to compare and calculate. So we can make this 4/3 pi times r over 2 times r over 2 times r over 2, which is equal to 4 pi r cubed over 24, or pi r cubed over 6. Now we can set up a simple equation where we simply cross multiply and solve for x. So on the Earth side of the equation, we have 4/3 pi r cubed divided by $100 trillion. And on the Mars side of the equation, we have pi r cubed over 6 divided by x. Now we can just cross multiply and solve for x. So 4/3 pi r cubed times x equals 100 times pi r cubed over 6. We can then simplify this further by dividing both sides by pi r cubed, and we get 4/3 x equals 50 over 3, or x equals 50 over 3 times 3/4, and the answer comes out to be $12.5 trillion on Mars. Now you might be thinking, that calculation didn't include anything to do with population, infrastructure, environment, and Mars doesn't have any people on it, it doesn't have any infrastructure, and it doesn't have a very habitable environment. So we're going to look at a calculation that includes agents that provide value, including people, organizations, infrastructure, and the environment. So for Earth, we're going to say that the money supply is 100 trillion again, to make it easy to calculate. And then we're going to say that there are 100 billion agents providing value on Earth. And then we're going to say on Mars, there are 100 million agents providing value. And we're solving for how much money should exist on Mars again. So we can jump right to the cross-multiplying exercise again. And we have 100 trillion divided by 100 billion agents. And we equate that to Mars, and we have x over 100 million. So we can simplify this a little bit simply by taking out all these zeros, and we get $1,000 per agent on Earth. And we equate that to x dollars per 100 million agents on Mars. So once again, we're going to cross multiply. So we get 1,000 times 100 million agents, and we can simplify this. And the answer we get for the money supply on Mars is 100 billion. All right, for this third calculation, we're going to try to incorporate the complexity of society. And we're going to use the formula for the number of diagonals in an n-sided polygon. So the formula for the number of diagonals for an n-sided polygon is n times n minus 3 divided by 2. So I'll do a quick example here with a square. So the number of sides is 4. 4 times 4 minus 3 over 2 is 2. And you can see the 2 diagonals there in the middle of the square. So we need to quantify complexity. So we're going to start with a base complexity of 100 for Earth and 10 for Mars. Same money supply for Earth as before. The base complexity is our n. So for Earth, we calculate out 4,850 number of diagonals, and for Mars, we calculate out 35 number of diagonals. So Now we just do the same cross multiplication exercise that we've done for the past two calculations. And we get 4,850 x times 3,500 trillion, and x equal to 3,500 trillion over 4,850. And that comes out to 0.7216, or $721.65 billion. So, how much money should exist on Mars? In this video, we did 3 comparisons and associated calculations. These comparisons were really just intended to give us an idea of how we could approach this problem. We compared the volume of the 2 planets, we took an agent-based approach, and we took a complexity-based approach. In all 3 calculations, we kept the money supply on Earth constant at $100 trillion. And here are the results of our calculations: $12.5 trillion, $100 billion, and $721.65 billion. This is the first of a series of videos on Martian economics. If you'd like to get ahead of the curve, you can check out my mini book on Amazon titled Martian Economics, A Guide to Redesigning Monetary Theory on Earth.